Algebra 2 7.3b, we're going to divide radical expressions. If you haven't seen the previous videos for Chapter 7, you might become lost. We've got quite a few here. We've got 7 of them before this one. You can click on this video's description to watch those, all right? So I'll leave it up to you. You can watch this video, but if you start to become confused, I would go back and watch those previous videos, okay? The quotient of the square is the square of the quotient. Well, all that's saying is that we can write the quotient of a and b under one radical sign. And this symmetric property of equality gives us a rule for dividing radical expressions. To divide radical expressions with the same index, that means the same root, okay, the same k, we divide the radicands and simplify if possible. So we're going to get into what happens when these are different coming up soon in future videos. But for right now, it's saying these have to be the same, okay? All right, so let's see what we've got here. We can divide then simplify by finding roots if possible. I think you're going to get this. This is pretty easy. We can write them under one radical symbol. We divide 80 by 5 and get a 16. The square root of 16 is 4. Wasn't that easy? Let's try a cube root. We write this whole thing under one radical symbol with the 5 on the outside because it's in front of the radical symbol, see? And we do our division. 32 divided by 2 is a 16. We've got 5 times the cube root of 16. That 16 needs to be broken into a perfect cube. Because of that little root out here, we need to find a perfect cube. And 8 is 1, because 2 times 2 times 2 is 8. So we split it into an 8 and a 2. And we can factor this. And because this 2 is to the third power and that root is a 3, we can pull this radical symbol off and just have it as a 2. We remove the radical sign, the 3, and the exponent, and we just have 5 times 2 times the cube root of 2. Because that's not a perfect cube, it stays underneath the radical sign. We multiply the 5 and the 2, we get a 10. We have 10 times the cube root of 2. Okay? Let's try one that's a little bit harder, and I want you to remember what we've talked about in the previous videos about even roots and odd exponents. When simplifying an even root to an odd exponent, we use absolute value bars on the variables. So we have an even root of 4, and when we simplify it to a 3x, that x only has an exponent of 1, which is odd. It's an odd number, 1, 3, 5, 7, 9, odd numbers. So because it's simplified to a 3x, that x needs to go into absolute value bars. It's an odd from an even root, okay? So take a look at this one. We've got this fourth root that we can write under one big radical sign. And do you remember the quotient rule of exponents? It says that we subtract exponents when dividing. So if we have x to the 5th divided by x to the 2nd, it's x to the 5 minus 2, which gives us x to the 3rd. Okay, so we're going to subtract exponents. Well, if you look at this one, it's got this denominator has a -1 exponent for the b. And if we're subtracting, that means we have b to the 3rd power minus b to the 1st power. So that's a 3 minus a -1. We're already subtracting. 3 minus a -1 means 3 plus 1. We add the opposite. So this 3 minus a -1 is going to become a positive 4 because we added the opposite. When we divide the 32 by the 2, we get a 16. There's no a here in the denominator, so it's going to stay a to the 5th power, b to the 4th. Now we find perfect fourth roots. And 2 to the 4th power is 16, so now we have 2 to the 4th power, a to the 4th power, b to the 4th power, and there's our straggler a. Because we had a to the 5th, so here's the 4, and here's the other one to make 5. So he's a straggler. He's not a perfect fourth root. He's going to be off by himself under his own radical sign. And because this is a fourth root, and these are 4 exponents, we can pull all of that off and just have 2 absolute value of a and b times the fourth root of a. And they're in absolute value bars because their exponent is a 1, and we came from an even root. Okay? Let's try this one. This one's a little big one. And we're going to write the entire thing under one radical symbol. We're going to do 189 divided by 7, which is a 27. And we have the cube root of 27, x to the 3rd, y to the 5th. Now what we do is we subtract. So x to the fifth, take away x squared, is going to be x to the third. And this 7 minus this 2 is going to give us a 5. So now, because this is a cube root, we need to get cube roots in here. So 3 to the third power, 3 times 3 times 3 equals 27, so that's perfect. We've got our x to the third, and we can break the y into a y to the third times y squared. Now, because that's not a perfect cube, he's got to stay underneath the radical sign. So now we can pull this radical sign and the root and all these exponents off of this because all the 3's match, and we get 3 times the absolute value of x and y times the cube root of y squared. And this x and y are in absolute value bars because we're not sure if they're even or odd, okay? Now, does that xy really need those absolute value bars? Well, they are at an exponent of 1, aren't they? But what's our rule? Our rule says it needs to go from an even root. Is this an even root? It's a 3. So no, we don't even need these absolute value bars, do we? It's only when we go from an even root to an odd exponent, okay? So that's just going to be 3xy times the cube root of y squared, all right? Just remember, even to odd, all right? And remember your quotient rule, and remember that when you subtract a negative, you add the opposite, okay? Our next video is 7.3c. We're going to add or subtract radical expressions. I'm going to add this video to the Algebra 2 playlist so you can study. And there's going to be links to Algebra 1 from last year when we talked about dividing radicals from 11.3, 11.4, and 11.5. This is the actual video, 11.5. There'll be links in this description so you can just click on this. And I'll have a link to the 5.6 Algebra 2 factoring review video that talked about all the different ways of factoring polynomials, okay? That'll put it right at your fingertips. It's a beautiful day outside here. I hope you're having a good time, and I hope you're doing well in class and in school and everything's okay. And keep trying. I believe in you. I'll see you next video. Bye.